for our this coming weeks, right? Okay, let's continue from where we have stopped. Okay, so 2 days ago, we discussed about one important issue in blockchain. Okay, which is scalability issue, right? Scalability, huh? All right. Hey, how come I don't have the projection? Oh, I freeze already. Okay. Okay, so to tackle this issue, okay, we learned that there are few approaches. Okay, we have layer one, later solution. Okay, we have a sidechain which run side by side with your main network. Okay, uh, because of this, okay, not every transactions might go to your mainnet, right? Actually, this you perform for off-chain transaction over here. Some transaction you can move over here. You don't need to use your mainnet, right? Okay, but somehow you have a connection that allows you to transfer whatever access from the main network to the sidechain, or the access from sidechain to your main network when necessary. Okay. And then the security of this sidechain usually is will be purely depends on its own the security mechanism, right? It does not need to depend on the security provided by main network. Then we have another layer two solution, okay, where we build another network on top of the main network, right? Okay, so you need to have one initial transaction here, and then you can do all the transactions in your layer 2 network there. Okay, then you just bundle all the transactions into one single transaction and commit back to your main network. This is how it works, right? Okay, so the same strategy with your side chain. Okay, you also perform off-chain transaction here. Okay, so off-chain transaction also happening in your layer 2 scaling solution. All these are called scaling solution. Okay, because it help you to scale your main network, right? Okay, so for layer 2's scaling solution, you have all these example over here. The one that we focus on will be this one. All right, so you must know this one well. Okay, so this is the this layer one solution. So where you change the size, you don't change the size of the block. Okay, it's still the same. Just that you move all these thing, witness data. They are called witness data. And move it somewhere, but you still maintain the 1 MB size of block. This is for Bitcoin. For Bitcoin. So that you can accommodate more input transaction, output transaction. So you are more scalable now. Okay, sharding. So the concept of sharding is to just do partitioning. You break this network into multiple partitions. So these partitions will only need to take care about the transaction assigned. Okay, so here this partition also the same. You don't need to handle all transaction. Remember? Oh, now you have more time. Okay, then you can do more job Okay, if all the nodes in all the partition also like this, that means now you can handle more transaction, and once again you are more scalable. Okay, so this is the idea of sharding. For information, I think Ethereum not yet. They're supposed to have completed. If I'm not mistaken, I haven't checked the news, latest news. Okay, so sharding in Ethereum actually not yet completed. Very soon, maybe a few months later. Okay, you can keep up with the development by yourself. Side chains is the one running side by side. Okay, so it depends on its own security. It's good for you to do some testing on the new blockchain platform they want to build. You can use it because you won't kacau your existing main network one. You create a new protocol, new blockchain platform. Go ahead. Okay, to test up there. Maybe you just have bridging to allow the transfer of assets from your sidechain to your main network, or main network to your sidechain. Okay, so these are the examples like Polygon network, XDAI, and so on. Examples of Ethereum. This is sidechain for Ethereum because it's connected to Ethereum. Liquid is an example of Bitcoin's sidechain. They have their own sidechain. Okay, it depends on the which mainnet you are connecting to. Right. Okay, so this is an image. It looks like this side by side, right? You need to have a two-way pad for the bridging. Those details are important just for information. Okay. For layer 2, so we have state channels, roll out and plasma. They are almost the same, almost only. You want to know the detail in the study your own, but you just focus on this one. We do roll out. Okay. This is for the lightning network. Okay, roll up, there are two types, optimistic and also zero knowledge roll up. The difference is how you do the this summary validation, right? You remember, whenever you use a layer 2 solution, you need to commit back a summary back to the main network, right? Then how to trust the summary is valid or not valid? Someone need to check, okay? So here, if you are using this type of roll up, it will require more time because it assume nothing wrong. The summary okay. This assumption. Maybe you wait for 7 days. I cannot remember how long. Maybe around 7 days. They leave it there. The summary you commit back to the mainnet is okay. No problem one. No fraudulent transaction insights and so on. We assume we assume you are not guilty, right? And until I find the proof, right? Evidence, right? Something like this. So it will take time. So after it has been confirmed, only you can withdraw the money that you deposited when you joined to the layer 2 network at the very beginning. Right? You need to deposit money to certain smart contract account. This is how you join the layer 2 network to use the layer 2 network to perform the transaction there, right? But if you are using zero knowledge roll up, it will be very easy because it uses mathematical proof. Okay, use some very complicated mathematics inside. It involve cryptography. Okay, so you can disvalidate immediately. Oh, no problem. Yeah, your money you can take back already. So this is the one that is very promising. It will become more and more popular. Okay, so this is for Ethereum also. Okay, of course, apart from the layer 1 solution, layer 2 solutions, the side chain and so on, you can also have other way to improve the scalability of digital ledger technology. I use the word digital ledger technology. I didn't say to improve blockchain. You can consider use other digital ledger technology, DLT. For example, directed cyclic graph, DAC. Okay, this is a different technologies. It's not blockchain. This is not blockchain. Okay, what I want to say is, if you think you want to have a more scalable digital ledger technologies, this is also one of the digital ledger technologies. Okay, so how is it different from blockchain? Since I say it's not blockchain, yes, it's not blockchain because you won't see a block, you won't see a chain. So this is not a blockchain. But it is more like a graph, right? Graph, something like this. Okay, something like this. Okay. It's not. There is no block, right? There's no change also. Okay, so all these vertices over here represent transactions. Okay, so the transactions will be will refer to two previous transactions like this one. Okay, maybe my drawing no good. Okay, this one. Got 1 and 2, okay. This one no good, okay. So this one got 2 references, okay. Once the transaction is referred by others, it's confirmed already, okay. I don't want to talk into details. I just want to tell you that if you think after taking the layer, the first approach, second approach, and so on, still not scalable enough, you want more scalability. Things to do is change the whole thing, right? Change the design from the beginning, use another technologies. That's why there are other options for you. Okay, if you don't like blockchain, you cannot be standards, cannot make it to be more scalable. Think of other technologies like the directed cyclic graph. Of course, this is not perfect. Okay, you can get high scalability. This one can process up to 150,000 transactions per second. Wow. Compared to Ethereum, okay? It's a big difference. Huh? It's very fast and very scalable. However, of course, got some cons also, right? Oh, okay, nothing can be perfect. Okay, if you are trying to make use of this technology, maybe you need to sacrifice the decentralization part. When something is decentralized, that means it also will be less secure, usually. Okay, more centralized is not a good thing, right? Okay. Uh, single point of failure, single point of failures, and so all these things will happen. We're supposed to make it as decentralized as possible, like Bitcoin, very decentralized, very secure. Okay, so can consider other technology if you want to have more scalability. But at the end, it's not a blockchain anymore. Okay, it's another different type of digital ledger technology. You are still doing the recording, right? Transaction recording, right? But using a different technology that does not involve this block and also the chaining. Okay, so this is that. Okay, so before I go into another topic, let's do a quick exercise. I already prepared another practice set again. Okay, everyone. So go and log in into your Google Classroom. I want you to try out, because it's very important for me to make sure they have very good understanding on this scalability issue in blockchain. All right. So you go to your Google Classroom. You're supposed to be able to see, okay, the practice set already released to you. Okay, so this is the one. Go to your classroom. You'll find one assignment called scalability issue. Click on it. Okay, it's the same, very fast one, only a few questions, but it's very important. Okay, so everyone please try out. Okay. Okay, let's do this simple practice set in maybe about 5 to 10 minutes time. Okay, just answer a few questions. Right? I want to gauge your understanding. Maybe I should use another view, review work. From here I can see your performance. Okay, try to answer first. Later on, I will discuss with you quickly. Okay, some have done already. Very fast. Okay. Okay, so I give you 5 minutes time to answer those questions. Very easy. Many true or false. True or false. 50-50 chance. Remember to do your revisions for your practice sets also. Important. How come this one no update one? No real time update. I need to reload. Okay, Kisun finished already. Some need to have multiple attempts. Shouldn't be any problem, right? Because you have to do a quick recap before your exercise, right? Okay. Most of the things I have mentioned, I think. Okay, I give you another few more minutes before we discuss together. This is my first time to use practice set. Previously, I always use Kahoot. For every lecture, I got Kahoot one. But now Kahoot can only allow 20 students. Need to refresh. Cannot show real-time response. Wow. Okay. Most of you are done, huh? Okay. Most of you are done. Okay, I think I can start to discuss everyone how to go back here. Okay, we look at the questions together. Okay, first questions. Ethereum platform can handle roughly how many transactions per second? One answer is 15. Okay. 7 will be Bitcoin. Okay. This is just a rough figure. Okay. Roughly 7 or 8. This one can Ethereum can be 20 also, but on average roughly 15. Okay. So it's very, very low. The transaction per second, TPS. TPS is very low. Okay. So we need to tackle this scalability issue. Okay, why so slow? Usually public blockchain like Ethereum, we have this problem. Okay, the TPS is very low. Okay. So what are the reason behind? Okay, is it because of the consensus mechanism used? Is there any relationship? Oh, maybe proof of work, okay, proof of stake and so on. Okay. Like proof of work need to try and error, calculate the answer for the medical puzzle, right? It take time, right? If I don't calculate, I don't use this consensus protocol proof, that it will be much faster, right? Okay, okay, correct now. Okay, so it is not wrong to say, okay, that scalability issue actually got something to do with the consensus mechanism inside Ethereum. So this is correct. This is true. What about the decentralized nature of Ethereum? Would it contribute to the scalability issue in Ethereum? Decentralized means not centralized to one entity for all the processing, right? Okay, all of you need to process. Okay, you receive a transaction, you need to handle, you need to process. Okay, everyone needs to do so, and then you need to share out also. The transaction received, you cannot keep it. You need to broadcast, right? Get everyone in the network to receive the same transaction. You put it into your memory pools and so on, right? Okay, so you need to do a lot of things. In case this network is decentralized. Okay, so because of that also, it will cause a scalability issue. Okay, very hard to scale. When a lot of this transaction coming in, everyone need to handle, right? Okay, so that's why we have the idea of sharding. Sharding, they you need to handle all. It will increase your scalability. Okay. So this is also true. True. So sharding that we discussed, is it layer 1 or layer 2 solution? Okay. So it is layer 1, okay, not layer 2. Layer 2 we have state channel, we have roll up, we have plasma, right? But sharding basic is layer 1, okay? Later on you will know why layer 1. Okay. So which of the following will improve scalability by breaking down the blockchain into smaller independent partition? When you hear the keyword partition, you know there's only one scaling solution that do that, right? Okay, there is sharding. Sharding. I think it's not something new. Whatever technology used in blockchain is not new. Sharding also used in database. Okay, we do partitioning for database. The idea is already there for a long time. So pinjam, the idea you apply it to our blockchain to increase the scalability. So you partition the whole network into smaller independent partition so that you only need to handle some designated transaction. You don't need to handle all, right? So the answer for this one is sharding. Okay. Which of the following is a layer 2 solution? Savvy is not. This is for Bitcoin, where you move all those witness data to somewhere else. Okay, so you have more room for you to accommodate those input transaction, output transaction. So the answer is roll out. Roll out is a very typical example and the most promising this layer 2 scaling solution. Okay, roll up because you roll a bunch of transaction up. It's roll up. Then you commit the summary back to the main network. Okay. So which of the following enables off-chain transaction? You don't, our transaction don't come to the mainnet, go somewhere else. Go somewhere else. I can handle more others. Okay. So this is also a way for us to increase the scalability. We give you another options to execute a transactions. Okay. So here the answer is A1. Roll out. Roll out. Okay. Sharding is to partition, right? Okay. So the transaction still happen in the main network, right? Okay. Even though you handle less for every partition there, you handle less, but you still actually execute the transaction on your main net, okay, main network. Okay. But shardings different. No, sharding no such a thing. Sharding no such a thing also. Just want to confuse you. Okay, so remember, roll out is a very good example of layer 2 scaling solution that will enable off-chain transaction. This is what we want. Okay, we want to upload our transaction to another network off-chain to perform off-chain transaction. Do not want to execute. We don't want to handle the transaction on the mainnet. The answer is roll up. The last question, this is important for you to understand. Why just now I call this sharding as layer 1? Why sharding is called layer 1? The reason is because we make direct adjustment or changes to the main blockchain network, right? Okay. So it's called a layer 1. Sharding, we make changes directly to the mainnet, right? We partition it, right? Okay, got many partition, right? I'm not creating another network, right? No, right? Partition. So I have to make some changes directly to the layer 1 network, to the main network itself. So it must be called layer 1 scaling solution. Okay? It's one of the approach for scalability. Alright? We don't have layer 3 yet. Okay? So the answer is 1. We don't have layer 0 also. Okay, layer 1, either layer 1 or layer 2 scaling solution. Right? So remember this, that's why we call it layer 1 scaling solution, like sharding, like SegWit, also the same. Right? Okay, so that's all for the practices. So hopefully this will help you to understand better okay, on the auction or alternative that we have for us to scale the network, okay, to make it more usable. Okay. All right. We settled the scalability part. Everyone okay? Okay. If not okay, go back and do your revision. Okay. And all the practice set that I prepare is very important, and you need to relook into them, okay, before your final exam. Okay. Please also share this with your friend. Okay. All right. So let's continue with our next topic. Actually, there are many topics for us to discuss about blockchain technology, especially the issue. We love to tackle issue. Okay. So the next topic is related to privacy. Okay, privacy. Privacy is important. Okay, especially when you are using public this network. Okay, so sometimes we don't want to make our transaction visible. Okay? Sometimes we want to disclose selectively and so on. Okay. So this one will need to have some technique, like if you really want to, because you don't want to change the whole this blockchain. Maybe you do some workaround and so on to make a transaction this private. Okay. So there are some techniques over here. Okay. For example, we can do transaction anonymization. Okay. So how we do that? We don't want to make the transaction so obvious. You send 1 Ether to me, okay? From your account. You send 1 Ether to me. So direct, I can see this account send 1 Ether to that account. Everything very transparent, right? Okay. Okay, I try to confuse you. Okay. The thing I can do, if I don't want to make it so obvious, I can actually do transaction anonymizations. Okay. So I mix a lot of transaction together with other transaction. Okay. Transaction for other user on the public accessible blockchain. Okay, this is the mix. Okay. So this is used in this cryptocurrency called Dash. Okay, Dash. It's use this kind of technique. So the transaction inside, if you go to the explorer of Dash, then you not clear for you to identify where actually the money come from and so on. Okay, you cannot see the connection between the receiver and so on. Maybe the they make a big path. Do not go through directly. Maybe send to here, then send to here, then send to here, then later send to you. You need to do some tracking lah. Okay, it's not so direct. Just want to confuse you. Basically, the final result still the same. This account send 1 Ether to that account. That's all. I go to a big round. I send to you first. I break in into 2 transactions. Maybe then from here I transfer here. At the end you receive 1 Ether. Just because I want to protect the privacy. Okay. Actually, I'm not directly received from that guy. Okay, maybe from another sender. Okay. They are just intermediary. Okay, so this is called coin missing. Okay, you mix with other transaction for other user, make it complicated. And then also ring signature also you can use it. Okay, so the idea here is we use a ring of public key. A ring of public key. Okay, you still need to sign the transaction as usual. You're using your private key. Yeah, that one cannot run away. Okay, you sign the transaction using your private key, but you also combine all the public key, inside the ring. So there is a ring, a ring of key, a ring of public key is there, a lot of keys, and this key, public key, actually will be combining, will be combined with your private key. All these cryptography related process is called coining. Ringing. The ringing. This is very complicated process, very hard to understand. That's why I define. Okay, so you need to sign the transaction in this way. Okay. Then the recipient can verify using the ring of public key. You can verify. This is a transaction probably signed by someone, and then but it cannot figure out which one because there is a ring of public key. Many users different users will have their own public key in the ring. So you can verify it's signed, okay, they're happy already, but you want to identify, wait, among these 10 person, who signed, you cannot, okay? You cannot, you don't know, okay? So this is how it's actually protect the privacy, okay? And Monero, okay, is the one using this technique lah. Okay, it's another cryptocurrency. Don't worry, these are not so important because too hard for you to understand the how it work. Don't be so curious how it work because you know lah, cryptography not something easy to understand one. But what you need to know is, hey, there's such a technique called ring signature. Can do in this way, okay? Why very complicated cryptographic calculation and so on, okay? And then you can actually hide the sender, okay? Enough, The most important thing is the scalability, Okay, of course, zero knowledge proof also is an emerging technologies that we use to preserve privacy. Not only in blockchain, it's widely used now, okay? But it's not easy to use. First, you need to understand, okay? And then also it involves a lot of overhead. You want to do this kind of proof, okay? You require a lot of very heavy computation inside, and also a lot of setup. Before you can use it, you need to do some initial setup. That is very complicated. I tried to read the papers related to this particular technique, called zero knowledge proof. A lot of paper one nowadays. I don't have the stamina to read until the end. And to challenge yourself. So many pages. Out of mathematics, one line or two lines, you need to think for one day already to understand it. Until now, I cannot fully understand it. The mathematics behind all these are mathematics. Okay, very difficult one. You are interested, you can dive into it. Okay. There are many this zero knowledge proof technique. Okay, can use this zero knowledge star bulletproof supersonic. Very complicated techniques. Are not easy to understand. But the idea is very simple. As I mentioned to you, you don't need to tell me. Okay, whether you are over. You need to tell me your actual birth date, right? And I can know you are over 21 years old. I can sell wine to you, beer to you, and so on. Even secret and so on. Okay? It's very amazing. I have used one, the simplest example, 2 days ago, right? You want to identify Doraemon in the pictures, okay? It's hidden somewhere. How I know that you know the positions of Doraemon in that picture, right? Okay, you can cover it, you make a hole, just show me the Doraemon character there. No lah, you know lah, correct or not? It's this kind of concept. So in blockchain, actually we can use zero knowledge proof, this technique for various purposes. The one that I can tell you is the one that you learn, how to verify the summary, okay, committed by someone back to your this main chain, right? Main network, right? If you are using roll up, correct or not? At the end, you need to roll out a bunch of transactions and come a summary, and then when I get a summary, I don't need to. If I using this zero knowledge proof, then I don't need to have don't need to provide me all the transactions in your bundle. I will have a way to tell that it's valid or not valid. Is there any problem or not with your summary that you made? You don't need to show me the transaction one by one. If you have 1,000 transactions that roll out, okay? It doesn't give me. I can prove mathematically or cryptographically using this zero knowledge proof. So that's why you get this zero knowledge ZK roll out, this type of roll out, right? For you to do the validation, then you can get your money refund quickly, right? Fantastic, good. And it's used in other areas also, in data analytics and so on. Okay, not only blockchain, it's widely used now. Okay, and not easy to understand. If you are a programmer, also you don't know how to implement. Give you the library, also you don't know which one to call first. How to set up a long step. Very hard one, not easy one, but very useful. If next time our computational power getting better and better, right? Then you can see the implementation of this kind of zero knowledge proofs will become very common. They can be applied in many applications. Sorry, let me reject first. Sorry, Miss Kong. Miss Kong in the lecture. I call you later. Okay. So this is also one of the techniques. Okay. To preserve privacy, our purpose is to have the privacy on your transaction data. Okay. Also, another issue now. Touch and go only lah, privacy. Okay. Meaning to say you still focus on scalability lah. Okay. Okay. The next issue they want to talk about is interoperability. You know we have so many blockchain platform emerging. Okay, we got Solana, we got Cardano, we got Polygon, a bunch of new platform. Wow, all very good one. Because they are new. New always good. Because they will not repeat the mistake for their predecessor, right? Okay. Like Bitcoin a lot of problem, Ethereum also got problem. That Ethereum they're willing to upgrade to handle all the problem, right? Okay, they do a lot of upgrade from time to time. Okay. So many platform and so many assets created for that platform. Let's say you have Polygon, maybe you created certain token to be they can run on that platform and so on, right? So many you have so many things there. I have so many things. Okay. Then would it be interoperable? Okay, can my assets be used in your network, right? And so on, right? This kind of interoperability is very important for us to solve so that we want to encourage the transfer of assets amongst all the different network. There's so many different networks. Okay, how to do it? Also complicated. This one is very complicated. So we have project like Cosmo, Polkadot, especially Polkadot is doing well now. Okay. To handle this issue, I need to design another network that can interconnect those networks seamlessly, allow whatever we want to allow. Okay, so we have this project. So the transfer is important. Value transfer is important from one network to another. You must have a proper way of mechanism there to do this. So we have things like inter-blockchain communications. And also pet zones, idea like this. Once again, don't need to understand. This one will take you a few weeks to understand. But just know that yes, it's important that you make them interoperable. One thing, right? Second thing, yes, already people got some idea. There are some real projects ongoing. People pushing very hard to interconnect them. Okay. And you don't want to just have a small ecosystem for my platform. You can do this thing only. There are some very good things that I might want to take advantage of and so on, right? I want to connect them if they can talk to each other and so on. Allow me to transfer the assets. That will be fantastic, right? Or not? Okay. Of course, project like Polkadot that I mentioned is very popular. Okay. So this is how it looks like. Very complicated. Don't worry. Don't need to understand. Just need to know that there is such a thing. Such a thing happening right now. Okay. Actually possible for us to actually interconnect different blockchain platform. Okay. So the detail I'm not going to discuss here. Okay. Okay. Next thing. This is the one also important one. Topic. Access tokenization. Okay. So we want to turn whatever thing into digital asset, then we can do tokenizations. Okay, so we have a few types of token. We talk about token. We have a few types of token. First type is called fungible. Fungible. What's fungible token? Very easy. If you take this cryptocurrency example like Bitcoin, Ether, all these are fungible one. Why they are fungible? Because they look like the same. Okay. This one Ether here and another one Ether here, they are no different. Okay, there's nothing unique to this piece of one Ether and the other one also. They are exactly the same. Okay, exactly identical to another same type. One Bitcoin is equal to one Bitcoin. 5 Bitcoin also equal to 5 Bitcoin. Okay, and they can be divided, divisible into smaller amount. You can cut into smaller pieces like 10 Bitcoin. I can turn it into 10 pieces of 1 Bitcoin, right? Okay, you can do so. Then it's fungible. Okay, very easy to remember one. Right? First, identical. Second, can be broken into smaller pieces. Okay, divisible. Okay, and then we can exchange with another with the same value. If you give me this 1 Bitcoin, I can also give you another 1 Bitcoin. It's the same thing. I can exchange with you, no problem. Okay, can be exchanged, divisible, and identical. Then it's fungible, right? Example, okay, cryptocurrency law, Bitcoin, many others, right? And there is a standard design for this, for creating this kind of fungible token. You can create another token, okay? Durian token or whatever token. Since you are doing durian assignment, maybe you're interested to create a durian token, okay? Then you can, if you think that that tokens have the same value and identical to each other, can be divided to smaller amount, and then can be interchanged and so on, then use this standard. You follow this standard to implement. Okay? That's why we need a standard. Okay, so that your the token that you come up with, the create token means the smart contract you write. You write smart contract to create a token. Then your token can have all these characteristics if you follow closely the whatever required in this standard called ERC20. Remember ERC20 for fungible token, right? Okay, so this is an example of the interfaces of this standard. You can see the main thing to say, in one day I want to create 1 fungible token that will be identical, interchangeable, divisible, and so on. You call durian coin. Okay, then I need to implement in my smart contract. Of course, the token name will be durian coin. But you might have all these functions implemented. If you are saying that you are complying to this standard, you are following this standard, okay, you must implement all because you are following the standard. So here I tell you, so these are interfaces. So you might have this total supply. This is just a declaration. You need to define on your own one. Okay, implement one by one, balance of allowance, transfer, and so on. The function for you to transfer your coin and so on. Your token and so on. Okay. All you must follow exactly. Implement. Then your token basically is a ERC20 token. Okay. Like this example, you must implement is. In Solidity, no matter you are inheriting or implementing, they still use the keyword is. Okay, same one, confusing. Okay, no good. Okay, token is ERC20. That means this token that you are creating using a smart contract actually is implementing this standard. ERC stands for what? Ethereum request for comment. Basically, it's asked for the opinion from the public. At the end, you come up with this standard. Okay? Ethereum request for comment. Bitcoin also they have. Alright, then we have another type of token which is called non-fungible, just not fungible, right? Okay. Now the characteristic of NFT, basically this is MFT that you know. Okay, MFT actually is a type of token. Okay, so the characteristic of course is opposite to fungible token. Okay, it cannot be the same, cannot be identical, must be unique. Unique. So your token is unique one. Okay, there is no other token like your token. Okay, like CryptoKitty. One CryptoKitty is unique one. It's very different from others. There's no the same one. Alright, it cannot be divided. Cannot be interchanged also. Okay, like I have this CryptoKitty. I want to exchange with you another one. You cannot, because they are not the same. Okay, and it cannot be divided like this token, this one kitty, the kitty cannot cut into half, right? Okay, but your Bitcoin got 10 Bitcoins, you can break it into 1 Bitcoin, and so on, right? Okay, so this is not divisible. So MFT. Alright, so the standard will be different. You don't follow this. This for fungible token. When you want to create a token like this, you follow this. But if you want to create this one, non-fungible NFT, you follow this one. All these are the example of NFT law. Okay, can be anything. Collectibles, this famous one now. Voting right, okay, access right, royalty program lah, copyright, supply chain tagging. All this can be turned into a token. Okay. Okay, so this is the interface. It's not so short. Actually, a long list. When you are creating a non-fungible token, actually you need to implement a lot of things. This is just an example. Actually, there are many others that you need to implement here. Okay, why we need to follow a standard? Is it important for you to actually create a token by following some standard? Yes, it's very important to ensure interoperability. If other application want to use your token, interact with your token, they can know. They know what you can do. If I know you are non-fungible token, I can find what you can do from here. This list of interface, right? These are the things you can do. Other than that, you cannot do, right? Because you are non-fungible token, you comply with this ERC 721 standard, right? So if I want to do something to your token, then I know what function I should call, right? And not only these two, remember, not only these two standards, actually there is a bunch of standards out there right now, or a long list for different purpose. Take for example, we can tokenize our real estate, right? So I have given you this example, so I believe. Let's say there is a very expensive bungalow, right? Okay, so you want to sell, you can actually turn it into smaller pieces and sell it individually, right? So I cannot afford to pay 4 million to buy that bungalow. It's okay if you break it into tokens. Okay, say one token will represent a certain portion of the bungalow. Okay, maybe the selling price is not that expensive. Maybe 100,000, I can get one token, right? I just buy that share of the bungalow, right? I invest. I know that after 3 years or 5 years, that's not the bungalow 4 million one. We shoot up and reach 8 million. Wow, 100% increase. You want to buy or not? Because one, right? But you have 4 million or not? No money, 100,000 gone. Also no, I'm sorry, then I can invest. Okay, 100,000 I can still afford to invest. 4 million I don't have. Okay, you see, I can create token like this to represent this fracturize this property is a portion of the bungalow. Okay, and then I'm not necessarily I must use this even though it's maybe applicable, but I can use other standard. If you search through the list of ERC standard, you'll find one very suitable. I cannot remember the number already. It will guide you for this kind of purpose, because I want to I want to turn the bungalow into tokens, right? So I can find the correct one, the correct this standard for me to implement. Yeah, I want to create that kind of token that people can go and purchase, right? And what kind of things you need to implement? Then you need to refer to that standard and then implement accordingly. Maybe you find a function called freeze function for your token, so that people can freeze your token. Okay, you implement your smart contract. This is my token called property token, then got one function, because this function is specified in the standard, so I need to implement the function. It's called freeze. Why freeze? Maybe the authority find out you are actually involved in illegal activity, so you want to freeze the transfer of token and so on. Freeze your asset as well, so that portion of the property represented by your token, right? You cannot sell anymore, you cannot move, you cannot transfer to other people, it cannot be sold. Because authority can call this function to freeze your token. The authority can do so is because you implement according to that standard, not ERC 20, not ERC 721. It's another standard. It contains this interface called freeze token, maybe called free token. Okay, so it's important. So if you follow a standard, then we know we can actually do this kind of thing on your token, right? If not, I don't know what kind of function they implement. You just tell me ERC number. Oh, no, okay, I can do this, I can do that. Okay, I can get information like this from you and so on. I can do. So it's important. Okay, we follow to ensure people know what functions that can be called for a certain token, and then this will ensure the interoperability of tokens. Okay. Okay, so token also we can categorize it as utility token or security token. Okay, utility tokens basically means this is nothing to do with fungible or non-fungible. It's another story. Okay. So if your token is meant for you to access certain thing in your project, in your system, and so on. For example, when you want to access, you want to be able to store something on the blockchain-based system. Let's say file storing, a very good example. Okay, then you need to have token. Okay, for you to be able to store something, store some file and so on. The more you want to store, the more token you need. Okay, just like you're playing a game, okay. You want to play a certain game, you need to have token. Okay, if you are using that token for this kind of purpose, okay, for accessing certain resources and so on, okay, then it is considered as utility because you want to utilize utility token. Okay, right. For example, Filecoin is an example of utility token. So with this token, you actually can get access to space on this decentralized cloud storage platform. Okay, allow you show the token, you can use it. Okay, so this token is called utility token. And then we have another different type called security token. This is something that you cannot simply go and sell. Utility token is okay. You can distribute sell and so on, it's fine. Okay, because it is used for accessing the resources and so on, right? In your project, in your application and so on. But when you try to create this kind of security token, be careful. You must this get approval one. It's strictly control. Strictly control. Before that, I forgot. Every time I come to this slide, I need to really let you understand the word security. Security token here, I use Malay doesn't mean keselamatan. Security here refer to a financial product. Okay, financial instrument to be correct. Okay, financial this instrument for investment. Okay, you all know Chinese. If you still can understand, if you know Chinese, if I say 证券, maybe you know 证券. Okay, sorry for others I don't know in Tamil or in other languages. Okay, this is not the important thing. Is it's not talking about keselamatan. Okay, a different meaning. Right. Okay, then I can continue. Okay, so this one is highly restricted because of what? Because usually if you are selling this token, people buying your token, okay, basically they actually want to have a return. They want to get investment return. Okay, so if this token actually having this kind of characteristic is considered as security token. Okay, it's very different from utility token, right? It's just for you to access certain resources and the applications and so on. Okay, so it's highly regulated. For example, you must get approval. I want to start selling. Okay, you need to get approval from Malaysia. This security exchange. Okay, normally you need to get approval from or permit from this exchange. Okay. Okay, next topic. Okay, we're very close to the end of our last chapter already. Let me see how much time I have. Okay, 1 hour. I'm going too fast. Wondering what to do after that. Okay, so I try to drag make the story longer. Okay, so next we have this topic. Okay, forking. Okay, what's forking? Okay, so we always need to upgrade our software. Okay, this is not talking about your blockchain-based application. I'm not talking about that software. This is talking about the software related to your blockchain platform, right? Like Ethereum. Okay, they are running their software is called this Ethereum clients, right? Remember? Okay, every node, when you install, right? You want to participate in the network, you need to install client software inside the node. Okay? Okay, so everyone install the same one, okay? Install the same one. So all the nodes in the network behave in the same way, right? Because you're running on the same version of the software, right? Okay, so if this software run this consensus protocol, okay, then all will do the same thing, okay? So if one day you find out that this the protocol for your Ethereum, let's say, is no good, okay? Let's say initially Ethereum use proof of work or terok, very terok, right? Proof of work, you use a lot these energies, no good, right? So you want to change it, okay? So when you change, then you cause this to happen, okay? Forking to happen, okay? And it depends on how big is your change, how big is your change? Like migrating from proof of work to proof of stake, consider big or small? Big, right? Very big, totally different this consensus protocol. It's a big change, okay? When there's a big change, we have problem. When you have small change, it's fine. Small change, we call it soft fork, okay? The impact is not so big, okay? It does not require all miners and so on to participate, okay? And the upgrade, after upgrade, okay, it's still compatible with the previous versions. The previous version still can run, okay? And not everyone need to follow. This is soft fork. However, there are cases where you need to everyone to follow. Okay, you need a big change. Is the previous version is not compatible anymore. This is called hard fork. Okay, this very big functionality change, okay, and the old version is not compatible anymore. Okay, so there are two options for you. Those not participating in the network, let's say all of you. Oh, now I have a new software upgrade. So you have two options. One is to follow. Yeah, you go and download the new one, upgrade to the new version. Some are very stubborn. They want to change, okay. Okay, so you just follow the old news, old rules, You follow them. You no change to you, but there are some not going to follow the new rules. So hard forking will happen. That's why you see two different chains, okay, created. One is the original one, no change. Another is a new change. From a certain point, okay, you break up into two. Okay. So this happens before also, like Bitcoin example. Okay. So Bitcoin Cash forking happened because, like what we have learned, for scaling, we can do this technique called set week, right? Okay, so we can increase not set week, sorry. We can increase the block size. Actually, block size is very important to increase the scalability. The bigger the block, okay, naturally you can hold more transaction, right? And your transaction, the scalability can increase. Then why not just a simple solutions to all? Okay, some suggest to increase. I cannot remember the size already. I have a note here. Let me check. The originally is only 1 megabyte. Oh, no update here. Okay, I think the Bitcoin Cash, if you check, I think it's around 32. For 1 megabyte, it increased to 32 megabyte. Memory no good already. Bitcoin Cash. Block size. Originally only 1 meg. Block size. So some suggest to change the block size. Okay, so Bitcoin Cash, okay, expand the block size to 8 mega initially. Then later now become 32 megabyte. Yeah. So this is a big change. Everyone need to change. Okay. If you don't want to change, so you maintain, okay. Like the this Bitcoin that we are using now. Bitcoin now is still 1 meg. Okay, so that's why there is another coin called Bitcoin Cash. If you look at your if you have okay, Lunos and so on, actually you can do a trading for this Bitcoin Cash. That's Bitcoin Cash now. Do you think which one more expensive, Bitcoin or Bitcoin Cash? Bitcoin Cash the one that we higher block size, okay, larger block size. Okay, so do you think Bitcoin more expensive or Bitcoin Cash more expensive? Bitcoin is the one that not changed, still 1 mega one. Okay, what do you think? Your wild guess? Our friend, what do you think? You think Bitcoin is more expensive or Bitcoin Cash? Bitcoin Cash more, or got the word cash, or maybe more expensive. I tell you, Bitcoin today the price is mentioned ringgit, 127,000 ringgit, 127,000. Bitcoin Cash, they are from the same family one, only 1,000 ringgit. 1,000 ringgit, Bitcoin Cash. The symbol is this BCH. Okay. For Bitcoin, the symbol different. Symbol is BTC. Okay, that one is BCS. Okay, so this is a example of this kind of hard fork okay, so if you don't want to follow, you follow the old one. This is the Bitcoin that we have okay. So if you follow the new one, you have a bigger size for your block, then you call Bitcoin Cash. But the coin that you are using no longer the same, change. Okay, one is still Bitcoin, another called Bitcoin Cash. Okay, but the value different, the value is different. Okay, so people still mainly use Bitcoin. Okay, also Bitcoin, Ethereum Classic to Ethereum 2.0 and so on. All these are the example of hard fork. Okay. Okay, next. Okay, this is actually my last slide. Okay. Ayo, nothing. How come nothing? Got error. No lah, because I want you to think about the future of blockchain on your own. Okay, I don't want to guide you on this topic. Okay, so now after how many weeks of study, okay, I think you understand what is a blockchain technology. From the very beginning, you learn got block inside block got transaction they are all linked together via cryptographic link using hash function, right? Okay. And then got the proof of concept, proof of work, okay, and then the blockchain can give you transparency, can give you immutability. You can actually do more things when we have smart contract support. We just not dealing with simple payment related transaction. Or the story inside. You can actually store your program code into the blockchain and get executed when the conditions are met. Okay, then we know there are some this issue faced by blockchain technology like scalability, privacy, interoperability, and the one that I'm not discussing here is about security. It's a big topic. It's just security very important. I think that one will be more advanced I don't want to include in this introductory level course. Okay, security also is a big one, but it's a lot of things to discuss. Okay, how to write a secure smart contract, how to audit your smart contract, so to make sure no problem, because you know the characteristic of smart contract, right? Once it's written, you cannot change, right? Once it's inside the blockchain, you cannot change. So security consideration is very important, but it's out of scope for our course. Okay, so you know blockchain is like this of the pro and con, what it can be used for and so on. Okay, so do you think that there is a future for this technology? Just like when MetaMask come out, right? Wow. Okay, a lot of people doing the project related to MetaMask, become very hot. Okay, hot topic. Now, do you think MetaMask quiet already? Right? Still a future for MetaMask? Do you want to wear this headset all the time for the rest of your life? Do you want to have a second digital life? Okay. Would you love to wear headset for maybe 10 hours per day, let's say? No one? No one want? So how to proceed in the case? And of course now AI is getting hotter and hotter, right? For this year, right? Oh yeah, ChatGPT and so on. People are shifting focus to AI. A lot of big company closed down their MetaMask division. They don't recruit anymore, and then they stop the project and so on. They move to AI. Try to develop application related to AI and so on. Yeah. So what is my question? That's about future. The future of blockchain. So you need to think to me, of course, it's important because we are moving toward this Web3. Remember, because of Web3 support. When we have this direction, okay, we want to decentralize everything. Okay, so in future, maybe 5 to 10 years time, you cannot see any centralized application and everything will be decentralized in Web3. Maybe you have good control over whatever things owned by you. Now the big tech company cannot make big this earning from you like Facebook now. They earn a lot because you give the whatever you post become the assets, right? Okay, whatever video you post and so on also the same. Okay, now so if you move into Web3, it's different story. You have the control over the data. If you want to shift platform, also very easy. From Facebook to another platform, so because data owned by you, you can actually migrate easily and so on. Okay. All right. So I would say it's very promising, even though it's progressing not so fast. To me, it's not so fast, but sooner or later, because others new development like this central banks digital currency, central bank digital currency, okay, that every country now is moving forward to. Okay, I think so they must use this technology because it's very secure. You have the technologies that really secure, okay, the transaction, especially involving money. All right, okay. So I think it will be better than MetaMask for sure. Okay. Some of you are maybe from RST. Anyone from RST? No? Okay, no, I don't think so. Okay, maybe you do a lot of work with this MetaMask. Okay, but it's questionable for Meta. To me personal opinion. Blockchain, there is a demand for it. This is based for trust. When you want to do decentralization, the decentralization is your direction. Remember, whenever you do decentralization, actually you're removing the third party in the middle, right? Okay. When you don't have the third party, what will happen? You might not trust, right? Because you pay the trust on bank and so on for the transfer, whatever, right? So actually remove the trust also. So how to get back the trust? We need a way. We use blockchain. Blockchain is the base for trust. When this is still valid, right? You still need to use blockchain unless you can have another alternative that can give you the trust better than blockchain technology. Then you can say bye-bye to blockchain technology. Okay, it can happen if someone come up with one very good brilliant ideas on how to do this and so on. It might happen. Okay. Okay. So I leave this topic to you to think . So today we'll go back before you sleep. Think about this. Don't think about Dr. Wong. You can forget me, but think about this topic. Very susah. Want to drag the story long. Maybe now time for you to ask question maybe. No question. I don't. Every time no question one. Okay. Maybe I will ask you one question Okay. Just everyone need to. We have how many of you? Can very quick one. Just tell me what you have learned. One topic one a few words only. Don't tell me the whole content. Okay. Okay. I look at here. I want to start from here Okay. Give you 1 minute to think first. Okay. What you learn. Okay. Don't repeat. This is the activity usually we will do. Okay. Okay, so you are so lucky so many things for you to say Okay, just tell me one thing that you learned for the whole course. Consensus protocol, very important topic. So he now aware that there is such a thing called consensus protocol when we are talking about blockchain technology, right? Okay, don't understand this item only. Must understand why we need that consensus protocol. Why we need it? Why we need it? Very important. Okay, our friend. What did you learn? Anything? Just anything. Say anything. I want to drag the time on me. Sorry. Okay. Pardon? Type of currency. Okay. Now he get to know this some native currency used in blockchain platform like Ether, Bitcoin and so on. Okay, very good. Okay. Kacau. Okay. What about you?
Fungible token.
Fungible token, yeah, getting from today's slide. Very good. Okay, I go from here. Our friend? How Merkle root, Merkle tree. Or how you get the Merkle root from Merkle tree. Very good. Still remember. This is a topic long time ago already. Okay, our friend? Once again? Characteristics of blockchain. You can remember all. Tell me one. Good. I will ask all. Don't worry. Good. Yeah. Characteristics of blockchain very important. Immutability transparency, decentralization those things. Traceability a lot. Okay. So very suitable for us to use for many applications. Hey, our friend. Yes. Yes. Transaction fee. Wow. Everything about money. Yes, transaction fee is very good. Something that you cannot see in conventional web application, right? You don't need to consider transaction fee, right? Okay, our friend? Scalability, yes, very good. That's a recent topic. Okay, our friend here? Proof of stake, yes, good. How it work? Don't need to tell everything. Do you know how it works? Yes or no only? Very good. Proof of stake. Okay. Our friend, maybe? Okay. Yes. Blockchain process. Okay. Understand, everyone? Okay. So he understood the blockchain process. The rest also should be the same. Ask yourself, how does it when you first initiated the transaction, then what will happen and so on, later get confirmed to the ledger, right? Get added to the ledger, right? The whole process everyone must know. Okay. Okay, so okay, here. Yes? Getting less and less. You kanchong already. Proof of work, good. Okay, proof of stake, proof of work, okay? The latest one. The latest one. Okay, good. What's the difference?
Bitcoin Cash more value.
More value. I just want to mention Bitcoin Cash only 1,000, right? Okay. The main difference is the block size. Block size. Okay. Okay. Our friends. Need to think so long. Just anything, don't worry. Looking at the note also, you cannot say even one thing. Hyperledger. Okay. Hyperledger is a what? What is Hyperledger? You mentioned, but I don't know. It's a project only. The one that you can use is Fabric. Like the Ethereum, you can write smart contract. That one is called Fabric. Hyperledger Fabric is the full name. Hyperledger Fabric, which is a permission. Okay. Or consortium, you can configure as consortium blockchain also. You can actually use for business application that emphasize on the confidentiality, privacy, and so on. Alright, okay, thank you. Okay, then, okay, up there. Yeah, I asked you already. No, yeah, okay. Peer-to-peer network is one of the important thing because you need to have a way to broadcast, to get information from your peers and so on, right? Peer-to-peer network. Okay, very good. Okay, our friend there. Huh? Cryptography. Zero knowledge pro. Okay, very important also in blockchain. Cryptography like public key cryptography, those are important things, right? Okay, next one, your neighbor. Encryption. Okay, related to cryptography lah. That's why you sit together two of you. Okay, our friend. What? Decentralization, one of the very important characteristic of blockchain. We want to do that decentralization. That's why we have blockchain. All right. If anything is centralized, the application you want to is centralized, you don't use blockchain. Okay. It against the purpose. We want to do decentralization. Okay, our friend. Smart contract, yeah. Okay, without smart contract, then we can finish our course in 2 week times already. Okay, because a lot of things that we discussed are still related to smart contract. Without the smart contract support, initially, we only can limit our transaction to normal payment and so on. Okay, okay, our friend. Yes, here. Can you alert him? Yeah. Uyo or Ching, cannot remember her name. Now you're looking which chapter? Sidechain, okay. Sidechain is level 1 or level 2? Layer 1, layer 2? Okay, sidechain is very interesting. Some say layer 2. But arguable one, no? Because layer 2, the security should depends on the main network. This is one of the characteristics of layer 2. Security come from main network, like rollout and so on. If you are saying sidechain is layer 2, is security also should depend on main network. But it's not, right? Sidechain actually running its own security mechanism, right? It does not depend on. So it's very hard to say it's layer 2. But some, if you search online, some will say layer 2. Okay? Arguable, okay? Nothing wrong. Arguable only, Alright. Okay, our friend. There. Can someone relay the message? One second, sorry. Digital? Oh, digital signature. Okay, good. Why we need digital signature? Sorry, relay here. Cannot hear also. Okay, basically is for transaction. I mean the usage of digital signature in related to transaction is to show that you are the author of the transaction, who initiate the transaction, and also the main transaction that I receive when I do the verification, the transaction I receive has not been authored by anyone. Okay, I can confirm 2 things. No, with your digital signature. Okay, one is that it's really you are the one who initiated. Secondly, the content inside no change. These 2 guarantee if I can verify your digital signature. Okay. Okay, your friend sitting beside you. Consensus protocol repeated. Who said consensus protocol just now? Someone here. Okay, next thing. Cache function. Hash function. Oh, hash function. Okay, hash function. What's the purpose of hash function? No encryption, no? Hash function is not for you to encrypt, okay. For basically the usage is for you to do integrity checking, whether certain thing has been changed or not, right? Okay. That's why you use hash function to link this block to another block, right? Okay. So if someone changes the hash content, the hash value will be changed also. Okay, moving down. White shirt one. Okay. Huh? Mercury, just now mentioned by someone. Advantage and disadvantage of peer-to-peer network. Oh, okay. Okay, our friends typing. Yeah, cannot think of any. Wow, getting less and less. Oh. I think you learned a lot of topic. Huh?
Type of trade in blockchain.
Type of
Trade.
trend.
Yeah, in blockchain.
Type of
TRIE.
TRIE. TRIE. Okay. Okay. I don't know. Three or try. Okay, you know lah. Is that one lah? Okay, good. Wow, very difficult one. I can think of that. You love that topic. Our friend. Sharding. Okay, recent one. Okay. Oh, kanchong already here. Huh? EVM, what's that? What does EVM stand for? Okay, why we need that? To execute your smart contract, right? Okay, you only understand bytecode. Okay, bytecode will be executed by EVM. Okay, your friend? Here. Okay. Okay, your turn. Just name any. Trilemma, okay. So we cannot secure everything, we cannot get everything, okay. We need to sacrifice one, right? Okay. So what are the three things inside this trilemma? And forgotten. Security, security, scalability, decentralization, and security. We cannot, impossible for us to have these three at the same time. Okay? Okay? Yes. Huh? Oh, you answered already. Oh, forgot already. Sorry. Okay, our friend. Oh, the process of DF development. Okay, good. Okay. All right. So these are the topics that you have learned. Hopefully, you learn something okay, from this course. Of course, I don't think everyone will have a chance to work maybe after your graduation, right? Maybe they are not involved in this blockchain-based this project, okay? But who knows, okay? Maybe you get the projects in futures and so on, okay? So this one only will serve as a foundation for you, okay? When you have a project, then you really need to learn other things like the platform that you have chosen and so on, the platform that your client want and so on. This is just a fundamental, okay? Fundamental course only. At least you know what is a blockchain. At least you know what is a smart contract. At least you can differentiate the development between the conventional application and blockchain-based one. What will be the difference? Okay? Okay, good. Okay, so before we dismiss, so I need to give you your PIN code. So do you still want PIN code? Still needed? Anyone here will be bar? I don't think so, right? Yeah. Ririga, why? Your friend never share with you? Okay. Let me get the PIN code.